The goal was audacious.
We're seeing G on the order of 11.
To find out if life could ever have existed on Mars.
Signal's Odyssey is still strong.
And if the planet is safe enough now for human explorers.
Valid range. Vigil is separated. We have fire on the ground with the radar. Standing by for backshell separation.
Just getting to the surface was risky.
We are in powered flight. 500 meters altitude. We found a nice flat place. Standing by for spectrum.
Requiring technologies never before tried.
Sky green is started.
Her journey was going to be complicated and dangerous.
Signal Odyssey remains strong.
Tango Delta nominal.
All alone on Mars, the robotic rover would have to learn and adapt.
UHF is good. Touchdown confirmed. Proceed.
And so would her human handlers. We are down. But where are we? There's the peak of Aeolus Mons, better known to the team as Mount Sharp. Our descent imaging camera is unexpectedly still working. We'll have an extra eye on the ground throughout the mission. And we are not alone. Mars Odyssey, Mars Express, and the Mars Reconnaissance Orbiter monitored the landing from orbit, relaying our telemetry through the Deep Space Network. Their timing was perfect. The high-rise camera aboard the reconnaissance orbiter captured us descending on parachute. The day here lasts 24 hours, 39 minutes, 35.24 seconds, nearly 40 minutes longer than an Earth day. It's called a sol. Above, high-rise has found us. The back shell, descent stage, our heat shield, even craters left by the tungsten ballast weights. We're about 10 kilometers from the base of Mount Sharp, our ultimate goal. It's the most accurate Mars landing yet achieved. We deploy our high-gain antenna. Now, we can talk directly to Earth. It's time to put up our mast. Curiosity had done this once before, in a test at the Jet Propulsion Lab. After the long journey, it now works on Mars. We take our first good look around. The team names this location Bradbury Landing, after the author of The Martian Chronicles. His 1950s collection of short stories told of the colonization of Mars by people fleeing an Earth ruined by nuclear war. a series of NavCam images are assembled into our first selfie. Engineers had worried that dust kicked up by braking rockets would cover the rover. But Curiosity's decks appear mostly clear and ready for action. The team at JPL wipes more than 500,000 lines of entry, descent, and landing code, replacing it with surface mission instructions. Curiosity's onboard computers are a pair of radiation-hardened PowerPC chips bused to 2 gigabytes of flash memory and 256 megabytes of dynamic RAM. It takes the next 7 sols to upload and check the new software. Then, we are a spacecraft no longer, but a rover, eager to explore. Curiosity is a direct descendant of tiny Sojourner, the 1997 Mars Pathfinder rover, and a big brother to the rover's Spirit, now asleep on Mars. And Opportunity, still doing science about 7,000 kilometers away. Designed and built at NASA Caltech's Jet Propulsion Laboratory, every component of this rolling lab was tested, tweaked, retested, and refined. They sent power to the drive motors, performed a traditional shake and bake test, severe vibration, then heating and chilling in a vacuum chamber. They tested its ground-finding radar from an FA-18 Hornet jet and an AS-350 helicopter flying over terrain similar to Mars. They invented and perfected its supersonic parachute design. At the speed Curiosity would travel in the high Martian atmosphere, the chute would fill or fail in a fraction of a second. Test data would only have meaning if the team could see the failure modes. So these became the best photographed parachute inflations in history. They tried out their risky sky crane deployment with all of JPL watching.
2, 1, fire.
After long debate, the science team settled on a landing site, Gale Crater. At its center, Mount Sharp is built in layers, clays at the bottom, sulfur and oxygen-bearing minerals above, and complex channels carved long ago by flowing liquid at every altitude. The mountain offers a chance to voyage up through millions of years of geologic time on Mars. We've taken the frames of a complete panoramic picture now. Rocket blasts from our sky crane have scoured the surface in places which appear as light gray smudges. The geologists are fascinated by what the thrusters have uncovered. Curiosity's chem-cam finds its calibration marks mounted aft next to our onboard nuclear power source. By zapping bits of Mars with its infrared laser, Curiosity can tell what a rock is made of from up to 7 meters away. We target a fist-sized rock named Coronation, vaporizing a tiny area with a pulse hotter than the surface of the sun. We record the spectrum of the plasma ball from ultraviolet through infrared. The laser melts a spot less than 1 millimeter across. So we send a series of pulses to cover the mineral's variations. On Sol 20, ChemCam sends down its first raster of 5 side-by-side laser blasts. Our wheels print the letters JPL on Mars in Morse code to check if we're slipping on terrain. Rover drivers are eager to test Curiosity's navigation systems. Using visual odometry, the rover can drive short stretches all on its own. By Sol 26, we've driven over 100 meters, more than a football field length. Road test behind her, she's licensed to drive on Mars. Curiosity's reach for Mars began in the 3rd week of June 2011, when engineers bundled, bagged, and boxed the rover. Going from the high bay at JPL in California to the launch site at Kennedy Space Center in Florida took 36 hours, a specialized truck convoy, a C-17 military cargo jet, and some delicate moves with heavy equipment. In a clean room at Kennedy, each major component was final checked and reassembled. They had to finish on time. Earth and Mars only come together for transfer every 26 months.
5, 4, 3, 2, 1. Main engine start, 0, and liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
Launch day,
And we have first pair and second pair. Everything looks good.
November 26, 2011.
Ground jet.
Curiosity separates cleanly from its booster.
We have separation.
But that's just the beginning. Getting to Mars safely has proven very difficult. More than 58% of previous missions have failed to arrive. Cruising between worlds, Curiosity endures temperatures as high as 120 degrees Celsius and as low as minus 155 degrees Celsius. Flight engineers could make no more than 6 tiny course corrections to set up their perfect rendezvous with the red planet.